let's get started again. So I'm going to pick up where we left off. And but before I do that, I'm going to show you something that the reason why we ended up with CF show instead of NSLog was on the project type. It was core foundation I selected instead of foundation. So actually, it was kind of an interesting thing to do anyway. But I'm going to basically demonstrate to you, and you don't have to do this, but you can see it in a few minutes here. If I go into Xcode and I click on Create a New Project, and I select Command Line Tool, and I go Next. What I had done before is I selected Core Foundation, and it's Foundation. Core Foundation is the C version of it. It's why they make it so Foundation, Core Foundation, Coca Foundation, Coca Touchdown. So many different options. But if I go here, just test world here, and I select Foundation from the Foundation, and I'm going to keep automatic reference counting here. I'm going to do this actually for another reason as well. I want to show you the difference between the automatic reference counting and the not automatic reference counting. So if I select the automatic reference counting, use Foundation, this time I'm going to get a Objective-C program. I'm going to save it right here to my desktop. And now I have a main.m over here, and the main.m file is telling me that it's Objective-C, not C, like main.c we saw in the other one. And in here, instead of CF show, I've got NSLog, which is coming from NS library. And I'm going to go through all of the different syntax for NS string, NSLog, all these things. So tonight it's just basically orientation to the architecture, not necessarily very much programming. But we see the same structure. I'm sorry? Yes?
What is the difference between .m and .c?
Nothing more than a naming convention that tells Xcode what kind of file it should process it as. And it's interesting because it will do both. You can put C code in a .m, and you can put Objective-C inside of a .c.
So they are same.
In Xcode, they'll be treated the same. Outside of Xcode, you'll run into problems because the compiler is not going to know what it is you're talking about. The .c and the .m is just nothing more than telling the compiler. In fact, you get this with C++ as well. If you put .c instead of .c++, pp, on there, CPP, tells the compiler, hey, I'm C++. If you put .c, hey, what's this? I don't understand what you're doing here. Bad syntax. So it's nothing more than communicating with the compiler, actually. In this project, however, I could mix and match if I wanted to. In fact, I could have more than one class file in here, which we're going to see in a few minutes, and put in .c's and .m's and everything in here. It's sloppy, is what I was trying to say before, though. You should stick to one language, unless you really need to use a third-party library or something that's written in C, or something that is not yours, that you have to work with it. Know that you can, but in practice, you write everything in Objective-C, write everything in C, but not a combination of both. It's really bad practice. In fact, C++ programmers do it all the time. They think they're learning C++. They never create classes. They write a whole bunch of C code in there. Yeah, maybe they use iostream.h instead of std.o or something, whatever, stdio, but they're not really writing C code. So what do we get? Well, the auto reference counting. So before I was showing you the memory components here. So we see this auto release pool as an opening and a closing bracket here that is inside of our function. So if I were to just to take this out completely here, actually just ignore this part that I have highlighted here, and I see, here I'll just cut it, there we go. Now it's gone. This is the main part of it. They usually teach you on the first day of your C course or your Objective-C course. They go, every program starts out with a main. Well, main's inside of main. You don't actually have to call it main.m or main.c. You can call it my program. This is referred to as the driver program. It's the program. It's the application. You get the same thing in iOS. You get the same thing in other project types as well. It's what's making instances of all of the other objects and all of the other classes that you're going to create, they're going to put inside of this. This is the first class that runs, that starts a chain reaction and make instances of all of the other classes and make everything else work, which is why I call it main. Inside of main, you've got main. This is a function, sometimes referred to as a method or a message. It's a function that sits here by itself. This is not object-oriented. This has nothing to do with it, but it's in an object-oriented language. But we haven't programmed in object orientation yet. We've simply created a main. And if I left this alone, I'm going to have a problem. I have to actually put back in, and actually I have to correct the code now to put this at the end. I have to put this auto release pool back in here, and the auto release pool is basically doing all of our semi-automatic garbage collection for us. So what we have in here, and make this a little bit smaller so I can actually see it. Correct my code here. There we go. Oops. There we go. Correct my code completely here. All right. So what we have here is the template that they give you when you just create a hello world program. And essentially says, put your code in here, meaning this is where you're going to make all the instances of all your objects and create all of your memory that's needed. Instead of doing an alloc and a new, or doing an init and an alloc on a auto release pool or on something you're going to call a pool and then drain the pool, all you do is this. In fact, you don't have to do it. If you create a project of any type, we'll do it for you automatically in the main. Once you do that, there's absolutely no memory management that you have to do at any later point to release anything. So it's called automatic reference counting, which stands for, the automatic's pretty easy. Reference counting is what people wouldn't normally mean by reference counting. So every time you allocate memory, and this is going to automatically allocate. Maybe I can just undo what I just did there. This is automatically going to allocate. Anyway, we'll just leave it alone. I just clicked something here. And so when you allocate your reference, which means you're putting something into memory, and if it's sitting in memory, you have this thing called a counter. So the environment, let's just call it a runtime environment for lack of better words here, keeps a count of how many references you have out there. And what does a reference mean? If you make an instance of an object and you use the object, and you're using the object, you're referencing the object every time you go to the memory and use it, call it, talk to it, it's keeping track. Is there anyone who's using that? So the runtime environment is doing this for you automatically, and every time you goes out of environment scope, goes out of you were in a method, it's like that saying, with functions, what happens in the function stays in the function, kind of like Las Vegas, it's supposed to stay there. You go to a function, you make all this memory, and then you return from the function, and then where is everything? It's all gone. It's supposed to be gone. So that's a release normally if you were manually doing it. In an automatic reference count, it says, okay, you put something in memory, Are you referencing it anymore? Yes, 1. No, 0. And it keeps track of what is actually being used and what memory, so it can do what's called garbage collection. What's garbage collection? That's when you put the cans out on, actually my neighborhood, it's Tuesday night. They automatically collect the garbage in the morning. When we wake up in the morning and put the cans back in. Well, that's what the compiler is doing for you automatically. It's going sweeping through and saying, reference is 0, up, take it out. Reference is 0, take it out. Reference is 0, take it out. And it just sweeps through every once in a while your program is running. It's the same thing Java does. The JVM does the same thing for you, except the JVM is automatic 100%. The programmer doesn't have to worry about anything. That's why I call Objective-C semi-automatic. You still have to allocate. You allocate this way. So that's what I'm saying. In the future, perhaps this allocate, this auto release pool will go away. Why do we have to put that in there? Doesn't it normally allocate anyway? Anyway, you get this in the iOS development. You get this in the regular OS X development. It's just a way of, and I have an entire lecture on memory management. So that's just your introduction because it shows up in Hello World. Something else to show you.
We have to keep defining that auto release pool.
Every single program that you do will have one of those, and you put the entire program inside of it.
Only one for each file.
For main. And you'll see it as we go through some more examples. You'll see more auto release pools and how it's used. And I'm going to show you actually a couple more right now that will kind of reinforce the point. If you look at example number 1, so if you go to the code section, and in here, inside the folder, there's a subfolder called example 1. You click on example 1, and this is how you're going to do all the other examples I'm going to show you during the lecture part. And today we won't have any because half you people are missing computers. So we won't have any hands-on stuff today, but starting next week, what I do is I go probably till about 4, maybe quarter to 4, and then I give you something to do, and then you work on it, and I can see if you can do it or not, and then I walk around and I help you do it, because it's better. You sitting here listening to me talk is not going to help you program. It's better if you're actually doing something, but half of you don't have computers today, or you don't have Mac computers, so it's going to be impossible to sort of do that right now. Plus, it's kind of orientation day. But what you're going to do to get started in most of the examples that I'm going to give you in the project is you're going to have to click on something and it'll bring it up in Xcode, which means you'll have to have Xcode installed. So if you double click on the example number 1, it brings the project up for you. You don't have to do anything. In fact, it's not going to store or copy it anywhere on your computer either. It's just going to bring it up. And this is yet another example program, a little bit more sophisticated than Hello World. This one uses multiple classes. But it also uses an interface, and I want to show you, introduce to you the concept of what the interface and what the implementation is. And show you, another example here that's a step above Hello World. We're not going to write anything. Next week we'll write one this similar to this, hopefully. And it's no stress. If you can't do it, you just sit there and surf the internet or something, I don't know, or ask for help. And I always give you solutions to all of it as well, so you can just pretend like you did and open up the solution, if you wanted to. But here is a step above. If I run the program, it does nothing more than print some stuff to the output down here on the bottom, and it says total students in iOS something, total students in iOS 0. It's just got some, here on the bottom of the screen, it's printing out some information. And let's take a look at the structure of this program so we can sort of see what we're dealing with. And I'm going to compare this to an iOS program in a few minutes so you can just kind of see what it is we're working with. This is a project created the same way as we created Hello World. So we still have main.m. We'll always have main.m in there unless we change it to myprogram.m. So in here we have instances of objects being created. And you notice here that I'm not using an auto-read spool because I'm not automatically allocating anything. So I wanted to, now I'm going to have to finish answering your question. If you're not going to create instances of objects, and you're just going to do an nslog, or you're going to do a printf, and when I say nslog or cfshow, it's just put something to the console, output something, cout, if you're familiar with that, or printf. Then you're not creating any instances of objects, then you need to run it in something. You just create an auto-release pool. You put everything inside of there. All your C statements and all your stuff goes inside of that. If you're going to allocate instances of objects, you don't need what do you need an auto-release pool for? You're already creating the memory. You're creating the memory through your program, and this is using a pointer. And so you're allocating memory, you're initializing memory, and you're managing it yourself without an auto-release anything, without a pool of memory to work with. Instead, you're just doing it line by line. This is what we'll be doing in the class because this is what you'll be doing in iOS development. This is what you'll be doing 99.9% of the time. Unless you're writing Hello Worlds, which you don't want to write. So if you're doing it more of a sophisticated application development environment, you're allocating and you're initializing, which is definitely a lot more effective than just create a bunch of memory for me. Here, load it in memory. So let me just explain what this program is doing. We have multiple classes in this program. And I'm not going to go through, well, we'll go through a lot more detail next week, but what I want to do is show you the structure of this program. If we take a look at this, what we have out here is example number 1, which is equivalent to the directory. So this is the directory right here, example number 1. And in this example number 1, we have, this is just a project file you're never going to edit. This one you're going to edit, that one you'll probably edit, that one you'll probably edit. This one yet is another file you're not going to edit. So all these compiler-related files are the same files, are just created automatically and are used by Xcode, but you're never going to really edit it. Instead, if you look at it in here, you can compare it to what you see in the example 1 folder. Example 1 folder are basically this. So Xcode is nothing more than a visual GUI to control those source code files. So the same project that you looked at out there in the folder, you can work at a command line prompt and compile it yourself, or you can use Xcode for it. It's the same thing. It's just a shell to the command. In fact, it's the same thing for iOS development and everything as well. It's just a tool. It's not doing anything for you. However, you have project configuration and stuff like that to automate things and to help you. As an example, to go through a slight tour of Xcode, we have tabs on the top. Not the most user-friendly, I would say, in terms of the interface. There's tabs on the top to, build phases that include libraries, include third-party tools, frameworks, and stuff. Configuration, rules, build settings. You have sub-tabs in here. You have the window tabs. In fact, if you're sticking around for the iOS class, we're going to go through all that stuff tonight, so I don't want to really repeat most of it right now, but it's just nothing more than an elaborate IDE, which is my point. So what we have here is the main program, and it has a .m next to it. And then I have another file called student.h and student.m. The rest of it, just supporting files and stuff, is just project build stuff. So don't worry about all the rest of the stuff. Frameworks, it's Foundation Framework. Foundation Framework is going to give our header files. What are our header files? This is all this stuff here. Because it's actually part of the project, it's unnecessary to actually have to import it. So the hello world that imported that, remember I went through the differences between the quotation marks and the brackets? Unnecessary. You can actually pull it out just fine. You'll never see Foundation at the top of anything, especially if you're using Xcode. If you're not using Xcode and you're going to use the GCC compiler, then you need the Foundation. I'll show you an example of what that looks like because I've talked about it. I'm only going to do this once in this class because people don't like command line prompts. But if you go back out here to that getting started file, and don't want that one, don't save. I thought I had it opened. Well, I'll just open it up again. You see, there's a, in fact, let me just cut and paste this here, or copy and paste it. But before I do that, I'm going to change directories to the directory where I'm going to show you how to compile on a command line, and I'll show you the code that's being compiled so you see why that include or that import is necessary. If I change the directory to desktop where I have this stored, let's see. And you can actually, this is BSD Unix, it's underneath it if you're brand new to Macs. So any Unix commands, ls, cd, all that, very DOS-like. You don't have to take a full Unix course to understand it. It's actually pretty simple. What is a thing called code something, I think. Code. Change directory. Oh, it's an Objective-C. Objective-C. Hold on a second. See, that's why I have things pre-typed out, because I can't type. Code 1. Here we go. This is the other thing that's really nice about the Mac as well. You can just paste it in here. If I paste the command in, whoops, I'll say, here's the command that I pasted in here. It was GCC minus, framework, which means it's a switch to tell me what framework do I want to use. I want to use Foundation, and I'm compiling hello.m. If you get a bunch of error messages here, which I got actually because I don't have my environment variable set, you can use clang. Clang, this is really small. This is why I don't like text because it comes in too small for me. You can use clang, which is the same thing as a C language compiler, just the same as GCC. However, that's the Xcode version of it that got installed when you install those Xcode tools that's available outside, and it's basically going to use project paths and environments for you. So if I do that, it's actually going to work. So if I come back here, just clear this out so I have some real estate to work with. Paste it in here. Now I have clang frame. It's the same command before, but instead of GCC, I'm using clang. And now it should come back and good. So it came back correctly. It's GCC or clang. The switch for the framework, foundation is the framework, and then hello.m is the file, source file that I'm compiling. The -o is the same as GCC, meaning which is the name of the output file you're going to create. The output file I'm going to create is hello. In here I called it hello. So to run it, I just type a dot and a / and I type in hello, which means it's in the current directory. And I say hello world, which demonstrates too that this is an Xcode project. I just compiled it on a command line. So sometimes you might not have Xcode on a computer, but you have the GCC compile, or the Xcode is broken and you just need to compile it. You have that option. Or you're don't like Xcode. You don't actually have to use Xcode, actually. You can use a command line. Most people, 99% people would actually prefer Xcode probably, that's what I'm thinking. And I'm not going to command line compile because I'm not a command line compiler. But one thing to notice here is that the hello m does not use the, hello.m does not use the automatic reference counting. So if I take a look at hello.m, let me open it up in Text Wrangler here. I see this is the one that has a auto release pool. It's not using any automatic reference counting. It's not doing anything at all. So I put the automatic release pool in here. If I'm using automatic reference counting, I don't need to put this in here, especially if I'm not. In fact, this will work without this, even without using automatic reference counting. Here's why I say it'll work. You have a limited amount of memory that's already available to you. If you're just running hello world, it's just going to print something to the screen. It's not actually allocating and using any memory. It's not going to crash on you. If you write a full complete program and you don't manage the memory, you're going to have the same problem you have in C++. The whole thing's going to crash on you eventually because you're going to allocate. You're going to run out of memory because the release is to get rid of stuff that you've allocated so that you can make more room for more stuff you're going to put in memory. But if you're not loading up anything into the memory, then you're never going to have a problem. So it doesn't make any sense for hello world. But it's something you should consider when you start making more production development. So, yeah.
So I'm a little confused because the other program that you were manually managing the memory allocation, whereas here you are relying on the auto release pool. Did you say that you didn't want to rely on the auto release pool in the other program?
You don't have to. There's no need for it. In fact, if you put it in, you'll probably get an error message if it's not needed, or a warning. So let me repeat the concept. If you're using automatic reference counting, you don't have to use auto release pool. You don't have to put it in anything, in any program at all. If you're going to start making instances of objects, it's better to do it this way, manually. I don't know if this is the right program. This is not the right program. Here it is here. This way, by going alloc, which is the way you have to do it. You can't use an automatic. You don't have that option available to you. With or without automatic reference counting. If you use automatic reference counting, then you do it this way. No auto release pool, no retain, nothing. Nothing done. Nothing is done automatically. Excuse me, nothing is done yet. Wait a minute, what did I say? If it's automatic, you don't have to manage memory. If it's not automatic, if you don't select automatic, you have to manage the memory. You have to put in an auto release pool, retain the pool, drain the pool, keep stuff in the memory. This is kind of like explaining the concept backwards, however, because traditionally, let's forget about automatic reference counting. Talk about traditional way of doing stuff. Allocate, 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 allocate. Which is what this is. This is traditional. Allocate, allocate, allocate. And the only thing different with this is we don't delete anymore, and we don't retain. We don't release. There's no statement in here that releases anything. If you look at really old, I think I have it actually. I think it's in the PowerPoint slide. I believe I have a really old program example. Let me find it actually. Drain the pool, release the pool. Here it is. This is not using anything. You see down here we have a pool drain. If we were going to keep some stuff in here, we'd have to retain, release. That's not automatic. That's manual. But it's the problem is we went through a couple of generations of Xcode and a couple of generations of modifications to the language. And Xcode added the automatic component, which gave us auto release everything. So we allocate, 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 and then it releases for us. So we don't have to release anymore, we don't have to retain, we don't have to drain a new pool, we don't have to do anything, actually. In fact, in Hello World, we really seriously didn't even have to put in an auto-release pool for that. If we're not using automatic reference counting, and we're going to allocate a bunch of memory, then we put an auto-release pool in there, which makes it semi-automatic, which means it's allocated, and we drain it. This is the auto-release pool, and we drain it, but we don't have to do any releases and retains for the reference counting.
So for that program, we cannot put the auto release, the one for the student one, you take all of
Yeah, because I think I have automatic reference counting selected for it. And in an automatic reference counting, if I put the auto-release pool, it'll give me a message that says it's unnecessary. In fact, if you bring up old code and you create a new project and you select automatic reference counting and it has retain and it has release on the memory, like on the object. So if this were the old days, I'd have to, on IO student here, I'd have to release it or retain it. Release it means get rid of it. So it's manual reference counting. So get rid of it. Or retain means hold on to it, I'm still referencing it. Don't deplete that reference count. And I seriously wasn't thinking about talking about memory and release tonight, but so we're kind of jumping ahead a little bit on the concept, but it's actually kind of a good spot to mention it. The problem is in the old days we never had any of this crap, and all this crap is made up by Xcode. None of it is in Objective-C as a language. Objective-C as a language, there's no automatic anything. It's all manual. Allocate, initialize, and then release or retain. So it's like new and delete. So if you're a C++ programmer, you don't have anything, nothing is automatic for you. New, delete. Objective-C, not using any of the Xcode features, allocate, release, or retain if you don't want to release it. You want to hold on to it. And then when we get to the iOS stuff, you see we have different weak and strong properties that we can set on objects to release or retain, which is what weak and strong is actually doing for automatic reference counting. But that's a totally different concept. So what ended up happening is people said, well, all this release, retain, release, allocate, all this stuff's too much work. Let's make it easier for the programmer. So in the last starting I believe in 4 point something, all of a sudden we have this new button that says ARC on it, automatic reference counting. And then that's when an auto-release pool became unnecessary. And then all of a sudden it was, well, it's automatically going to release it for you. So if you use the tools, you let Xcode manage it all for you, and you don't have to learn any of the memory stuff. If you're not using Xcode and you're not using any of the auto-release reference counting, or any of that auto anything, which is all configurable in Xcode, then you're working in the old days. So people who learned objectives, this is why every time they put out a new version of Xcode, people go, oh no, because everything keeps changing. In the old days, on the first day of class, I'd be teaching you allocate, release, allocate, retain. I'd be going directly to this. And unfortunately now I have to say, oh, there's a little button there for ARC. And then I gotta explain the button. Well, the button says, forget about all that stuff. You still have to allocate, but you no longer have to release or retain. So just think that you can take, and you never have to give back.
Yeah, I guess I was a little confused, because I didn't realize you still had to explicitly allocate.
You still have to allocate. You always have to allocate, but you never have to give back if it's automatic. If it's not automatic, you gotta give back. If you don't give back, you run out of memory. But if you're a hello world and you take, what are you taking? You're not taking that much. You probably could survive without giving anything back. That was the point I was trying to make with the hello world program. Why do we need auto-release pool in there? But if we don't put it in, Xcode's going to give us a warning message, probably. Hey, memory leak error. And memory leaks, well, we have dangling pointers and memory leaks, and we have both problems, believe it or not, with the automatic still. Nothing is perfect. Nothing in the world is perfect because even with automatic reference counting and all of the stuff done by Xcode, we still have programs that crash. We have programs that crash because we have a memory leak. What happens with memory when we allocate? Oh, automatic reference counter's on vacation right now. Oh, we allocated too much. And this happens in Java actually as well, so it's not just an Xcode problem. We allocated too fast, and the reference counter is working too slowly, not in sync. And then we get to a point, oh, crash. But it only does that every 5 times I run the program. Oh, okay, It's intermittent, and that's the worst problem to fix. And you go, well, it's the auto release. And then people go, okay, don't use automatic reference counting. So people take that off. Allocate, release, because then you can tell exactly when in the program you want to release and when you want to retain. So if you do it manually, you have more control. Because then you're not relying upon an automatic method to come through there and sweep the memory out when it's convenient for itself. You're going to do it now. So, but this project here has ARC selected, so I'm going to allocate, but I'm never going to release anything. And I'm not going to retain anything either. It's automatically retained or released, depending upon how it's being used. I don't know, did I answer your question? Okay.
And for people working on large projects, what is the standard practice? Is it to rely on the automatic or to do it manually?
Well, automatic's only been out for about a year. So when it comes to iOS, nothing is really standard practice. Hasn't been out long enough. Oh, which means a lot of people are still doing it manually and not selecting that option. If you have legacy code, it's all done manually. And you got their project's got a dozen or so classes in it. You're going to go through and take out, well, some people do. You're going to go through and take out all the releases and all the retains. And you have to edit all the code to work with it. And it's probably under an old project type to begin with. So they're probably doing it the manual way. Newer people who are just learning it now don't even know what release means. Why would you need to? You don't have to know release. You don't have to know retain. All you have to know is allocate. Just take and take and take. Never have to give back. Because your memory is unlimited. Well, theoretically. All right, back to example number 1. So what we're looking at is the structure of a real program and how something's going to look. How did we get student.m and student.h in there? Because when we created the project, we just got main.m in here. Well, we did this. We went up to here and we went File, New. And instead of making a new project, we made, down here, we made a new file. And we'll do this and I'll show you step by step how to do it. And we added a file into it. In this particular case, we added an Objective-C class. We have categories, extensions, and protocols that we're also going to cover in this class as well. I'm probably not going to do testing because of all things, testing is probably, you're not going to hit that until you have to do it for your job. And then you're going to basically use Xcode or basically use whatever the company has to be using for it. And that's an entire class in itself. When I create the object, in fact, I selected to create a new class. I have to give it a name like before. I'm going to call this one dog because we have person in there. Let's call this one a dog. And dog is going to have a subclass. Every object in Objective-C comes from NSObject. NS is it's just the same as object, next step object. Why do we do that? Because we have objects that are not. And if you think about it, you probably could hybrid the language and it makes it more flexible. Go with non-NS objects. Just go from object. If you're familiar with, I don't know, Java uses object by default. You don't have to say object, extend object. But in Objective-C, you have to say, hey, NS object. Isn't that a no-brainer? Isn't it given to you? But no, you have to say it anyway.
What is it? MS?
Next step, which is the name. Are you taking the next class at 6? Oh, I'm going over the next stuff in that class. It's the name of the company that Steve Jobs was working at when he originally came up with, and all the developers, Bill Cox, and I can't remember the guys, Tim Love or something like that, were working on this project to upgrade C to make it object-oriented. And I think the Love dude, he was working with, he was the Smalltalk guy. Don't quote me on this, I can't remember off the top of my head. But long story short, that was the name of the company, so it ended up being Step. So GNU Step was the compiler for it, and Next Step was the name of the company. So everything turned into NS. And where they came out with Coca? Yeah. So like Java. Coca? That's what I say. Maybe they're just, had a little too much coffee. Or cocoa. Yeah, where'd Java come from? Why do you call language Java? When it got Coca is the interface that's equivalent to the, I don't know. Coca is the UI, the GUI components. So to say that it's equivalent to Java is not really true. It would be Java Swing or Java AWT, Abstract Window Toolkit. Coca is equivalent to AWT or Swing, but it's for NS, and it's all running on NS. So all of our data types are NS, NS string, NS integer, NS object, everything from the object-oriented part of the house. And we still have all the C stuff. So we still have integers and floats and doubles and stuff. I should have a C primer for those people who have never taken a C course before. I actually have one. I have to find it. Because it's not bad, especially if you're not familiar with all the data types and stuff. So I'm going to add it to the project. I just selected OK. And what I was doing is I gave the class the name dog. And then when I did dog, now I have, look at this, I have two files that were added to my project. You can go ahead and do that too if you want. We're not really going to do anything with it. But it's just showing you an example of how we're building projects in this course. As we're taking and we're going to create new classes, and we're going to put the classes inside of the existing project, and then we'll make instances of those, and then we'll learn how to create states and behaviors for those objects, which is the big picture essentially. Yeah?
For the class is registered.
We have two. We have interface for the .h and for the .m we have implementation. And it comes in a set for the class.
It doesn't say class.
Yeah.
It says interface.
In the interface, where does it say interface?
In the header part?
Yeah. In the .h, it's always called an interface. Before you came in here, I explained that actually. So the class, and let me reiterate the point, the class, all classes in Objective-C come in the form of two files, equivalent to the C++ two files. But one's called, in Objective-C, one's called an interface, and the other one's called the implementation. The interface is always the .h, yeah? Oh, okay.
See, if you're in Java, you find class in class.
Yeah.
But then
Java only has a one file format, the .java.
Mm-hmm.
And interface means something completely different. You implement interfaces in Java.
Correct.
You actually do the same thing. You have the same concepts, but you have protocols and categories. You have different ways of creating, protocols are like interfaces in Objective-C. That's more intermediate level. I'm not going to talk about that tonight.
It doesn't have any word like class. You want to say create class.
Correct. There's no class word in there. And that's kind of an interesting concept because everywhere else in C++ we have the word class. In Java we have the word class. In Objective-C we don't have class. But we're calling it a class.
Yeah.
Which is, well, actually in Smalltalk we don't use the word class either. But we're calling it a class. So this is, Objective-C is more like Smalltalk than it is C++. But, so if we were looking at the components here, we get by default import foundation X, which is what we're going to, .h, which we're going to get anyway by default. As I say, you could probably pull it out, be okay, but I would just leave it in. Yeah?
So then we have part of the discussion when we say class that means interface.
Nope. A class is really the combination of the interface and the implementation together.
Then,
Yeah.
Yeah, together.
So I don't mean just the interface, I mean both the interface and the implementation. And it's the combination of those two files that define the class. The interface in C++, you can just write one C++ file. You don't actually have to use a template or a specification for it, which is equivalent to the interface. So in C++, okay, in the beginning of C, we had main, remember that part, and then inside of main we called functions. And if you put the function on the bottom, below main, the compiler didn't see it yet, doesn't know what it is. So as you're going line by line through a compiler in C, it goes, print me. Print me? What's that? It doesn't understand print me. So instead, we created function prototypes. And we took the prototypes, and which is what you're putting in the interface class, actually. We took the prototypes and we put it at the top of the program. And the prototype said, oh yeah, we're going to have a function that's going to be called print me, and it's going to take on an integer. Okay, so then it came through main, oh look at print me. And then as it came, oh, I know that one. We'll just skip it. It was basically to satisfy the compiler, so that we're not using something we haven't defined yet, you know. And then underneath main, because it compiled component by component, so main was one component, and print me was another component or function, actually. And it was all separated out into different functions. So C is characterized by functions. No objects in C. It's all functions. And then we take this language and we turn it into an object-oriented language, and we're going to break out this file into multiple files, and then we're going to have to organize it. Well, then people say, well, take all the prototypes and put them in a separate file, call that an implement, call that a specification, or call that, in this particular case, an interface. Because in C++, it's technically called a specification, but people are starting to use the interface because it's more accepted. It's an interface. What is it? It's just a definition of everything. In fact, if we look at the interface file here as students, we see function prototypes, but the functions don't look right because they're in the wrong format. And this is what I'm going to be talking about next week. I can't cover the entire language all in one lecture. But we have really odd syntax. We got minuses and pluses, and we have data types, and we have that follow, kind of a cryptic format. We have this at the beginning interface, then we have an at end at the end, We have this really odd format to it, but it really just is nothing more than a bunch of function declarations or method declarations that says, we're going to have these data components, and we have 2 integer data components, and then we're going to have these 3 functions, and here's what the functions are. So when I say prototype, it means, it's kind of like not working. It's just a definition. It says we have a function called print, we have one that's called set undergrads, and we have one that's called set postgrads. Okay, those are 3 functions. And then in the .m file, we have those functions implemented. We have the same stuff in here. We don't have the data in here, but we have this function here that says set undergrads and set postgrads, and we have print. Print's right up here. And I'm going to go over the syntax next week, so don't worry about it. But the concept being we have a bunch of templates or specifications or interfaces, and then we have the implementation, which is why this is called an implementation. And the implementation says, this is what the functionality is going to be for this particular method. We want to take integer and have it equal to this number here plus this number here. And do an NSLog, print out the total number of students, yada yada. And then we have an opening and closing bracket. This essentially is a function. Looks like a function. The format is completely different. If I were writing this in C, for those people who know C, it would look more like this. We'd have, actually here we'd have void, prints, and then we'd have our opening brackets and our closing brackets. And in here, oops, it's going to put it in there for me automatically. We might have integer I or something. And we'd have, it's a totally different syntax. And it looks kind of like main. When we saw main, it was just following a C syntax, which is kind of odd, actually. But remember, we could put C inside of Objective-C. But what we're doing is essentially, in the implementation, we're adding the method bodies. Why do we want to do that? Well, because eventually, we're going to use it as a precompiled header. Precompiled header. All right, so in C, this is where the concept comes from. You're getting a lot of history today of C. Right. Everyone who's taken a C class knows you've got to include iostream.h. Actually, that's C++. Or stdio.h, and string.h, and all these. Okay, those are header files. Those are the .h's. That's exactly the same as this interface. You're including the interface file. In fact, that's what we're doing here inside of main. We're including up here on the top student.h. Why do we want to do that? Because the compiler is going to take the .m, student.m, and precompile it for us. Every time we compile this program, why do we have to continuously compile program code that hasn't changed? Every time you compile a C program, why do you have to keep compiling iostream.h? And does it change? No. Hopefully it doesn't change, otherwise you're going to ruin your compiler. So you have object code, which are stored in .o files for object, that are in a directory of your compiler, and it gets linked. So it goes through compilation. It takes this main program, compiles it, and takes the precompiled header, the student.h, links in the student.m precompiled code that turned into student.o that's sitting in a repository of other .os, or whatever you want to call it, out in a directory somewhere, usually in the include directories, and links it, merges it together, creates the executable for you. Same concept with Objective-C. Same concept with your files and you're creating. So when you do this, student.m is only going to be compiled one time. It's going to sit there unless it changes. If it hasn't changed, it's not going to be recompiled. It's just going to sit there. What does that do? It promotes reuse. We're reusing the same code. It's in the same repository. So all I really have to do is include student.h in every program that I want to create a student object for. And down in my student object, oops, I'm actually out in main here. In my student object, I'm creating a student here. Student, I'm using the object, and I'm going to get into object instantiation next week. Because we're not going to write this tonight. Way too much for the first night of class. But this helps us create a repository of reusable components that we can use in any program that we want. As an example, a year from now I decide I want to reuse this component for student. Well, I don't have to reinvent the wheel, I just include student.h. It's kind of like how you include iostream.h. You don't have to worry about how that's implemented, which leads to encapsulation, but it's also reuse. And it's called a precompiled header. It's precompiled object code in this particular case because it's given to us, we're reusing it. So when we create student.h, it's done. We leave it alone. It's in this project. It doesn't have to be in the next project. So as long as we have it, we import it into the next program that we're going to create, and we can reuse it without having to reinvent it. So you get a team of developers that work together and make all these classes that sit all in the same repository. You just include the header file, and then you use the functionality. So you can build it, which is one of the benefits of object orientation, promotes reuse. So you can reuse code in multiple projects, and it's all linked together. So it's basically comes out as saving time for the programmer, usually. So, yes?
Do we have a concept of how do we access variables? Don't we have a concept of getter and setters the way we have in?
Oh, we certainly do, but that's way too much overload for tonight. I will be getting into setters and getters next week.
Okay, so we do have the concept.
Oh, yes, we do. Actually, we have properties and synthesize that does our setters and getters for us automatically. But we also, if we don't like that concept, we create setters and getters. All right, what's a setter and a getter? By default, in Objective-C, all data members, and what's a data member? Well, here we have some data members, which is why I pulled up this project. Remember I said objects have three components, identity, states, and behaviors. States are data members. And here we have two data members. These should just think of them as two integers, two pieces of data. By default, in Objective-C, they're private. And what does private mean? It's only accessible inside of the class. You cannot access this outside of the class, which means if I want to change the value of this particular, or if I want to get the value of this particular data, I have to run a method. And these are the methods down here. So normally I'd have one that says set undergrad, get undergrad, set postgrads, get postgrads, and when I run the method, it sets or it retrieves the value of the variable for us without actually having to access the variable. Strict rule, highly enforced, promoted, Objective-C. Other languages, Java, you can break the rules all the time. C++, you can break the rules all the time. Objective-C, it's really hard to break the rules with it because it forces you to follow. The language environment forces you to follow it. But in the old days, people used to make everything public. And then out in main, what does that mean? Out in main, instead of running the methods on the objects to change the states, I can just change the states. It's like me telling you as a student, your name is Becky. You didn't go through a formal name change process of going and running a method that says student A dot change name to Becky, and it went through a test to say, hey, do I want Becky? Is that okay? Otherwise, you can my name's not Becky, and then you can come back and reject it if you want to. What does that do? Well, it enforces the integrity of the objects, of the data, making sure that the data is only changed by the allowable rules that are available. So it protects the object, makes the object last longer. So in inheritance, we still have private stuff, and we still have public stuff, but we also have protected stuff, which means inherited classes can change things, but the outside world can't. Those are called access methods, and that's going to be, in fact, I guess this is a good topic to overview for tonight because it's kind of a hodgepodge of everything I'm going to cover in the next 2 or 3 weeks. But that's another concept that we're going to spend at least some time on in terms of examples and stuff. I'm giving you, I guess, a pretty extensive overview of the language. So here I have dog.h and dog.m. If I go up into main, if I want to use dog in here, I just include it. I go include, let's see. And notice now I've got those quotation marks as I mentioned before, dog.h. And I'm using these quotation marks because it's in the same project instead of those brackets to say that's in the compiler directory. When you write your first program next week, you're going to essentially, have to decide, would I use quotation marks? And then some people just use quotation marks for everything, and then they figure out, oh, we can't do that. Or they come up here, what's the syntax? No, it's import. Oh, and remember I mentioned before, import is used for Objective-C foundation classes and objects that are created with the Coca interface and all of the Objective-C foundational libraries. Is dog and student part of that? Not really. So we can include it. When we include it, it's the same as an import. It means the same thing. In fact, I can actually put the word import over here and import it instead of including it. And the compiler's not going to complain. The compiler's going to use it just like it's going to, oh, import, oh, yeah, you need include, but okay, I'll take it. It's just going to work the same way. But it's standard practice to include if it's in your same project. It's not a standard NS library kind of concept. If it's NS library, you're going to import it. So there is a slight difference from the compiler's perspective between import and include. Include gets garbage collected, import doesn't. So import will go through reference counting, will go through everything else. When the object's out of, it'll get gone. Import is controlled by the runtime. Slightly different management, not handled the same way in terms of allocation of memory. In fact, import is more efficient. Because remember back in the old days when they taught you, it doesn't really matter what you include. It doesn't actually really matter what you include because only the function you're using is going to be, and if you're not using anything in there, it's not going to be brought in. Same concept with the includes in Objective-C, but on the imports, whole object comes in. But the runtime environment is controlling it. So if it doesn't need it, it will discard it. But it loads slower because you're taking and importing the entire object library instead of one function or nothing. If you're not importing anything, you've included it, like here I've included dog.h, but I'm not really using it in my code, so nothing's going to come in. But if I imported it, the whole thing's going to come in and it's going to say, hey, we're not using anything. Okay, take it out. So it'll eventually correct the problem. So it can affect how the speed of things loading and unloading and stuff like that. But it's not really a big concern. If I go include, I know I created it myself. It's more C-like, or C++-like. If I leave it out, what ends up happening is this particular file, this class does not know anything about the student. And next week, I'm going to talk about the concept of pointers. Let me take a look at the times, 5:30, okay. Went overboard. So next week, I wanted to end a little early because I have to do some registration on some folks. And we were supposed to end at 5:45, but... So a lot of the stuff, if you're brand new to programming, a lot of the stuff that I went over tonight is way overboard. Not on purpose, it was sort of accidental. When I start explaining things, I have a tendency to move ahead 10 steps. So what we're going to do next week, if you come back, is that we are going to start writing some code, working on a few concepts. One of them is going to be pointers. So we're going to create mains. We're going to create a program and by scratch, by typing the code in. And we're going to create instances of objects, and I'm going to talk about pointers. And then for about half the time. And then the rest of the time, I'm going to give you I have a little handout thing. I'll give it to you, and you're going to see if you can do it. So it's like listening to it, digesting it, and then doing it. It's not like graded or anything. It's just an in-class act. And then I'm going to walk around. I'm going to help you. So make sure to bring a computer next week. I have 3 loaner systems, as I mentioned before. The loaner systems are just like this one, actually. They're Barb refurbished systems because I like to tinker with electronics. They're all working. They all to a certain they're all working. And they don't leave the classroom though, because I can't afford my personal systems. But for those people who are delaying the purchase of a MacBook, it's a temporary fix for you so that you can participate if you don't have the right equipment yet, and then you can decide maybe by the end of 5 weeks or so whether or not it's something you want to continue doing. You can't take them out of the room though, but I will make them available. We meant to bring them this week. I'm going to bring them and leave them here at ICU so I don't have to remember to bring them. But it's a nice, that kind of screens are kind of small and stuff, but it's a nice way of participating without having to buy a computer right now. So, questions, comments, concerns? So what's your homework? Do I give out homework? I give out homework. Here's what you want. Here's what I want you to do. If you're going to continue, what I want you to do is skip all the examples. Don't worry about the examples. Go out to that website with those free PDF files. Download a couple of those books. If you came in late, let me show you what I'm talking about. And if you came in really, really late, I can give you all the stuff that you missed. Also, I've been recording the lecture. Everything is reproducible on the YouTube site. The links for the YouTube site will be in here. So out on my YouTube site, I have every single class I've ever taught for the last 2 years out there. So you can relive the past. But if you go into Spring 2013 and you go into Object-Oriented Programming and Objective-C, in here it'll say Spring 2013 video lectures. And the first one is how to install Xcode for those people who may have looked at it already from the meetup. I put the little link down there. By probably tomorrow or the next day, you'll see first class meeting with the date. So you'll see, and it's broken out into 2 videos actually for tonight because I did one before the break. And you'll see the stuff recorded. So if you missed the beginning, you want to relive it, you can. You don't see anything from the class. All you see what's on my computer, so you don't get to see it. But your recommended homework, if you're the homework type and you want something to do, click on this free legal ebook in Objective-C programming. Browse through the Objective-C books at your leisure. Pick 1 or 2 of them, download them, review it, look at it. You're going to want a reference book because eventually you're going to go, what is NS string again? What's the syntax for that? and you can't memorize that stuff. Instead, what you do is you find a couple books that you like. So explore the site, find the books that you think are going to be the most helpful for referencing stuff. Install Xcode if you haven't got Xcode installed yet. If you do have Xcode installed, if you have some familiarity already with Objective-C, you have books already, you don't not looking for any more books, and these books are free, by the way, so it's not going to cost you anything. Then go through the rest of the examples. This is the advanced homework for those people who want a more challenging homework assignment. Go through the rest of the code 1. See if you can make minor modifications, which is what I'm going to start doing next week. I'm going to start out making modifications to the person. I'm actually going to fill in the dog code. We'll make some dogs and cats. And we'll make instances of them from main, and we'll figure out how that works. But you can go ahead and experiment with making some sample projects. Use the command line interface. I don't recommend doing any GUI stuff yet. Next week, I'll show you the GUI stuff. But for the beginning, it's a lot easier to comprehend what it is you're doing with the command line. So if you're going to create new projects, use this command line tool. Use Foundation and use automatic reference counting. Create some projects. See if you can mess around with. And in fact, if you download one of the books, you'll see every Hello World program possibly imaginable. Some of them asking for your name, some of them printing out your name. Mess around with it on your own, get familiar, get comfortable with it. And then next week when you come in, we'll see what you can do. No pressure, but we'll see what you can create. And then we'll see. Then that kind of tells me again what the skill level is.
Is there any specific book that you recommend?
Yeah, actually, okay, so it depends on your learning style, actually. The book that I like out of that list, I don't recommend any particular book because every student is a little bit different. If you go to this list here, the one that I like, nope, actually it's not that one, it's this one here, Head Start. It's an old book though. In fact, this is a couple versions old, and all the screenshots are old. Here's the problem with these books is, I don't know if you came in late or not, but they sell the current versions, they give away the older ones. Because Xcode changes every month or so. You have different features and you have different, but the concepts of the programming are the same. Some of the books here, I typed in on the top of the list here, on the search I put in Objective-C, because these are the ones that are going to show you more C code. All of them are going to be hybrid. You can't show you Objective-C without showing you iOS, without showing you Coca Touch or Coca. They're all going to be different in terms of the focus. Some of them on the top, these are nice, but there's a lot of reading. If you like the reading, then go for the reading. That's why I say go through and find a couple of them. When you find the right book, you'll know it because you'll start reading it and you won't put it down. And it'll go, ooh, wow, that's what she was talking about. And you'll start reading it, and if you don't want to read it, it's a bad book. Throw it away. Go back to the website and get another one because you're not going to read it. If it's torture, you're not going to read it. So I don't like to read. So I like the one here that's got a bunch of pictures in it. Screenshots and pictures and colorful pages and stuff. I look at that, that looks really cool, And then I can just kind of not have to read it, but I can see what it's doing. If you like to read, go for the reading ones. I don't recommend going out to the Apple Objective-C guide and reading that. Unless you're, I don't know, masochistic or something and you have nothing better to do and you want to torture yourself and make this a lot more work than it really needs to be. You can come out here and read away. You can spend hours and not learn a thing from the site. However, you could search on things with this site. And I don't know what you were going to say, but the searching features are not bad to find syntax and to find why something is a certain way. But to learn it initially, it's good for troubleshooting, but to learn it initially, I don't recommend it. But that's just my style. I don't know. What were you going to say when I interrupted you? Oh. You use the site?
Yeah.
Oh, okay. Do you like it? You have a different perspective than I do. Yeah. Yeah. Well, it's nice. It's a lot of reading. It's nice. Actually, some of the forum posts are
No,
nice.
having these sites are like, you have everything in one place.
Yeah. It is all enclosed in one place, and you don't have to go thumbing through a book. Yeah.
And in case if you don't understand, definitely do Google search too.
Yeah, problem with Google searching, and I recommend Google searching to a certain extent, but the problem with it is that you get legacy code. And you cut and you paste it and you use it, it doesn't work. Why is that? Oh, because it's been changed, and then all of a sudden you got, this is the new version, then you learn all the different versions of the same library. And you go, oh wow, now it's different. Or they're showing you, some of those examples are wrong actually, and they're showing you the wrong way of doing it. And then there's, if you look further down, there's a correction to it, or someone posted, oh, you know what, this guy's full of it, here's how you really want to do it. Or it's unnecessary, stuff like that, so. We're almost ready to just start the next one. Just give me 5 minutes. Okay.
Are you covering the
I am recording everything. Oh,
Coca with RJPC,
I'm sorry?
the Coca library? Are you going to use that one as well?
Oh, yeah. Coca libraries. Also Coca Touch, we'll see. It doesn't really matter which libraries. Because, in fact, okay, so these guys are wondering, we started tonight with command line. Next week, GUI. Week after that, iOS. It doesn't really matter because it's all the same programming. Whether you're doing it on a MacBook, whether you're doing it on a device, it's all the same. So it's all the same libraries and stuff. Well, it's different libraries, but all the same syntax, I should say. Okay, we're officially done. If you're from the meetup, come up here. We have extra paperwork for you to do. If you're an ITU student already, you may leave. But make sure you sign the attendance from the TA that's sitting in the back. So let me stop this.